In 6.3, we're going to be looking at introducing logarithmic functions, but first in part A, our focus is going to be on inverse functions. So inverse functions and functions do and undo each other. We already know a lot of functions that are inverses. For example, if I have x plus 3, if you add 3, the opposite is going to be subtracting 3, so x minus 3. The notation for the inverse, f of x, would be f inverse of x. So f inverse of x would be x minus 3. We use the little negative one in the corner to signify inverse. As you can note at the bottom here, the first function f of x, the inverse function is called f inverse. The negative one is not an exponent here, it's simply the inverse function notation. If I have 5x, the opposite of multiplying by 5 will be dividing by 5. So we'll have x divided by 5 as the inverse. Square root of x, the opposite of square root is square. So h of x being square root of x, the inverse will be x squared. And if I have x cubed, the inverse would be the cube root of x. We have two ways to write that now. Or it could be x to the 1/3 power. We're just going to use that format to keep things interesting, keep them fresh right here. Because 1/3 powers are also opposites of third powers. Power 3, power 1/3 being reciprocals. Okay, when comparing a function with its inverse, the input and output rules are reversed. Sorry, my V got a little sloppy there, so I tried making it bigger. But the input and output rules are reversed. That is the x's and y's. I've got a light flashing above me. Sorry about that. The x's and y's trade places. So, I'm going to use that knowledge to answer the questions here in this example. This is a table for g of x, so I can map from x to g of x going from left to right. Since x and y trade places in the inverse, I can map the inverse backwards from right to left. Okay, so if I'm looking for g of 4, 4 would be an x value, g of 4 would be 2. G of 4 is 2. But if I am looking at the inverse, in the original function that 4 was an x, in the inverse function that 4 is a y. So I'm looking for a y value of 4 and mapping that back to where it came from. It came from 3. So g inverse of 4 is 3. G inverse of 5, that's a y value because it's in the inverse, not in the original. So I'm looking for a 5. There's one right here. So that g inverse of 5 gives me 2. Then g of 5, here's the 5 for the x, maps to the g of 5 value of 0. Okay. So if I have a single table, I can read the function in inverse left to right and right to left. On the next page, instead of a table, we're looking at a graph. We have the same idea, but in a function, the input is the x value. So f of 1, 1 being x, gives us 2 for y. So f of 1 is 2. For the inverse, that 1 on the inside is a y value from this graph. This graph being a graph of the function f of x. So if 1 is the y value, the x value is 0. The x value is 0 for a y value of 1. F of 5, that's an x value, so it gives us a y value of 4. And f inverse of 5, that's a y value to the original, so it gives us 8 for the x value. Next, we're going to complete a table of values here for the exponential function 2 to the x and its inverse. We already have the value for 2 to the x. We're going to grab the value. We're going to take the values and use them to find the values for the inverse. We said x's and y's switch places. So these two columns are actually literally going to switch when I write the values for the inverse. The x's become y's and the y's become x's. So I can take the x column and put them down for the y's. -3, -2, -1, 0, 1, 2, and 3. And for the x's, I can put the things that used to be the y's. 1/8, 1/4, 1/2, 1, 2, 4, and 8. Now we're going to graph the inverse. Might as well graph the function as well on this table, on this grid. So I had -3, 1/8, very small, -2, 1/4, very small, -1, 1/2, 0, 1, 1, 2, 2, 4, and 3, 8. So this graph, the first one, is the original f of x equals 2 to the x. It looks like an exponential function. We know that those have horizontal asymptotes to get very close to the x-axis. They're very tall on one of the sides. Now we're going to graph the inverse. 1/8 is now an x value, and it takes us down to -3. Then 1/4 is an x value, taking us down to -2. Then 1/2 down to -1. Then at 1 we're at 0. At 2, 1. At 4 we're at 2. And at 8, 3. So this is the graph of f inverse. Notice that everything is opposite about these two graphs. The original function had a horizontal asymptote. And the inverse function has a vertical asymptote. The original function has a y-intercept, but no x-intercept. The inverse function has an x-intercept, but no y-intercept. You have fast growth for your exponential and slow growth for your inverse. Everything about them is opposite. That's what they are. That's what it means to be inverses. Now this function needs a name. The inverse of an exponential is a new type of function. We call it a logarithm, or more specifically, if the exponential function has base b, then we're talking about a logarithm with base b. So we can name this function here. The inverse function, since this was the exponential function 2 to the x, the inverse function is going to be log base 2 of x. I'm going to rewrite that because I really squished it into the page right there. This one right here, f inverse of x, is log base 2, a little tiny 2 in the bottom corner, of x. That would be how I would write the name of this exponential function. The word logarithm sounds strange sometimes. It's not one that we are familiar with, but so did the word quadratic and square root when you first learned them. They are inverses of each other, squares and square roots, just like exponentials and logarithms are inverses of each other. Sorry, trying to get to my pause. Can't get there.